All right, let's try another example here. Perform a full curve sketching analysis on f of x is equal to the square root of 25 minus x minus 3 squared and sketch out the graph. All right, so step one, domain. We know, because it's a radical function here, that 25 minus x minus 3 squared has to be greater than or equal to 0, which means that negative x minus 3 squared has to be greater than or equal to negative 25. And when I divide both sides by negative 1, x minus 3 squared has to be less than or equal to 25. When I square root here, remember the square root of something squared is just going to be the absolute value. So if I take the absolute value of x minus 3 is less than or equal to 5, then if x minus 3 is less than or equal to 5, x is less than or equal to 8. If the negative of x minus 3 is less than or equal to 5, then x minus 3 is greater than or equal to negative 5, which means that x is greater than or equal to negative 2. And if I put all of that together, then I get a domain of negative 2 is less than or equal to x, which is less than or equal to 8. All right, so I have my domain. Next, I'm going to my intercepts. So if 0 is equal to the square root of 25 minus x minus 3 squared, and I square both sides, then 0 is equal to 25 minus x minus 3 squared. I'm going to move the negative x minus 3 squared to the other side. X minus 3 squared is going to equal 25. X minus 3 is equal to, when I square root both sides, positive or negative 5, which means that x is going to equal 8 or negative 2. And I get x-intercepts at 8 and 0, and at negative 2 and 0. For the y-intercept, if y is equal to the square root of 25 minus 0 minus 3 squared, then y is equal to the square root of 25 minus 9, which means that y is equal to 4, and I get the y-intercept at 0 and 4. Step 3 for the symmetry. When I take f of negative x, I get the square root of 25 minus negative x minus 3 squared, which is neither odd nor even. So no symmetry here. For step 4, for asymptotes, for the vertical asymptote, don't have a denominator here. There is no vertical asymptotes. For my horizontal asymptote, is as x approaches positive or negative infinity. In this case, because my domain is -2 is less than or equal to x, which is less than or equal to 8, it never approaches positive or negative infinity. So there is no horizontal asymptote either. For my intervals of increase and decrease, I'm going to take my function if f of x is equal to the square root of 25 minus x minus 3 squared, then it's going to equal the square root of 25 minus x squared minus 6x plus 9. And when I combine the terms and change the square root into the power of 1/2, I get negative x squared plus 6x plus 16 to the power of 1/2. When I take the derivative of this, I'm just going to use the chain rule. And I'm going to get 1/2 times negative x squared plus 6x plus 16 to the power of negative 1/2 multiplied by negative 2x plus 6. Or (1/2) negative x squared plus 6x plus 16 to the power of negative 1/2. And I'm going to factor out a negative 2 from the second set to be left with x minus 3. And I can cancel out the 1/2 and the 2 there. Which means that I'm going to have negative x minus 3 all divided about the square root of negative x squared plus 6x plus 16. I'm going to solve my critical numbers. where x is equal to 3 from the numerator. And when I factor down that denominator, I get x minus 8 and x plus 2, where x is equal to negative 2 and 8, which is the same as the x-intercepts. It is also the same as our restricted domain when we do that first derivatives test. Remember, nothing exists outside of that domain. So I'm going to use the point of 0, I'm going to use the point of 5, and I find that my first derivative goes from positive to negative, which means that my function is going from increasing to decreasing, and I have a maximum that is occurring within that restricted domain.